Assalamu alaikum. I welcome all of you to the video lectures on basic concepts of chemistry. Today we will be discussing hybridization. As previously in the previous lecture we discussed the Sp3 hybridization, and we also discussed that how the geometries of CH4 molecules, the bond angles, the bond lengths, they were justified by the hybridization. So there are other examples, so we need to discuss them again. So we'll just go through it a little bit faster, because in the previous lecture we have discussed the basic of the Sp3 hybridization. So there are other molecules. Let's go to the NH3 molecule. This is an NH3 molecule. Now again, as you see that what experiments have told us, experiments which were previously performed via spectroscopic techniques or something else, they showed that the actual angles between the hydrogen is less than 109.5. okay, these are the angles between the hydrogens. They say that those angles are less than, the angle between these and these hydrogens are less than 109.5. Well, why I am mentioning 109.5? Because we should have some was or reference, or it is the simplest molecule of standard type of molecule which can be used to compare the other things. Okay, so these angles are now less than 109.5, less than 109.5 degrees, or in fact experiments have determined them to be 107, about 107 degrees. Okay, these angles between these hydrogens are. So how to justify this experimental values with hybridization. So I am going to discuss that a little bit. Okay, so what hybridization, what the experiments, old experiments, or the experiment told us? It told that all these bonds are of the same energies, and they all have the same angles. They all have the same lengths, and the angles between them are 107, or a little bit less than 105 or 109.5 degrees. Okay, so what is the atomic number of nitrogen? Atomic number of nitrogen is 7. Okay, so what is electronic configuration? 1s2, 2s2, 2p3. So let us write it here. In 2s there are 2 electrons present. In the 2p there are 3 electrons present. Okay, so energy, it is again Sp3 hybridized molecule. So its energies I have discussed in the previous video. If anybody is interested, so they should watch that. Okay, so again, if an electron is excited from here to here, or if it is not excited, case is the same, because if one electron is excited to here or here or here, so what will happen? One of the orbital, this orbital or this will become paired, and this will become unpaired. But so it's not, this excitation will not be a fruitful one. Okay, so again let me tell you one thing else. 2p, this is the energy. Why I am writing the arrow above? The 2s orbital and the 2p orbital. This 2ps has less energy than the 2p orbital. Okay, now here there are 3 orbitals. So as they are arranged in x, y and z directions in the Cartesian, according to Cartesian coordinate system or 3D system. So they have just named it. This is px. You can say this is px or this is px, no matter. Py, pz. These x, y, z mean that they are perpendicular to each other. Okay, so suppose no hybridization is done and we don't know anything about the hybridization. Let us explain it on simple unpaired electron bonding. So if we look to those things, again without hybridization this thing can form 4 bonds. Okay, sorry, 3 bonds. again with a px, py and a pz. Okay, so there are, because all these orbitals are perpendicular to each other, and let's assume that each has one electron present in it. Okay, these are perpendicular to each other. Okay, so what will happen? So it will form, suppose it forms a bond, so each bond, it can form 3 bonds, and each bond has an angle of 90 between each other. So nitrogen should form, this is one hydrogen, one bond, if you look to this thing. Okay, not the actual experimental values which are determined by experiments, because what hybridization is, it just explains things. 90 degree, 90 degree and 180 degree, and let's see that here the nitrogen keeps its lone pair in, or non-bonding electron, into 2s orbital. Okay, let's see that whether this molecule is correct or not. From correct I mean that whether it looks like in its characteristic to that of the one which experiments have determined. Experiment says that these bonds are equal. Yes, they are equal in energy, because there are 3 p orbitals. P, this is p, this is p, this is p. So nitrogen is forming, suppose, a bond with the hydrogen with its p orbital, and again a p orbital, suppose we assume, and again a p orbital. So this means that it is okay. Suppose this, let's suppose that we say that these are okay, these have the same energies, all p orbitals have the same energy, and they have the same length too. But one thing this molecule is not good at, and it is the angles between these hydrogen. Actually the angles are less, the angles which experiments have determined between those hydrogen are 107 degrees, but here we can say that it is 90 degrees. Okay, pardon me for one thing, that if a nitrogen is involving a p orbital, it will not form bond like this, because let me again explain it, because as you know that the p orbital is, this is a nucleus of a molecule, it's half here and half here. Okay, so this is one p orbital, it should have formed the bond like this. Okay, this is other, and the other one is like this. Okay, inside the board it should be in a tetrahedral, half out and half below. So it should form bonds like this one, this second, and the other bonds, the other orbital will be half lobe of the orbital will be inside the board and half toward you. So the other hydrogen should have formed the bond like this. Again, it is a 90 angle arrangement, but in the experiments say that it's not 90, it's 107. Okay, I was just explaining this thing because the p orbital doesn't make bond like this. As you know that the p orbital is a dumbbell shape, and it is on both sides of the nucleus, half there and half there. Okay, one lobe is on one side and the other is on their side, so this thing fails. Now let's come to the hybridization. What will happen if this molecule hybridizes? Again, in simple case, 4 orbitals combines together, forget about electron, and will give 4 hybridized orbitals. So you can have 4, there are 3 p's and 2s orbital, so you will get sp3 orbitals. How many? 4. Okay, 4 orbitals. So one thing you should remember, that among those 4 orbitals, 3 orbitals will have 1 electron each, multiply by 3. But one of the 4 orbitals will be having a lone pair of electron. Okay, so this means that the nitrogen can form 3 bonds and will keep its lone pair in a sp3 hybridized orbital. Okay, Now let's move to the energies. As you saw in the previous video that we just assigned some energies values, we just assume that the 2s orbital has 10 energy of 10 any unit, and the two p orbitals have each orbital has some energy of 12. We just assumed, and we came up with 11.5 energies. So if anybody want to see that, so go to the previous video and they will look at it, they will understand it a little bit more good. Now again, here is one thing else. 4 bonds from the Vesper theory, we know that if something has 4 things attached to it, it should be, or the angles between all of them should be 109.5 normally, if these things are charges, okay? Because here are electrons, these electron will repel each other, and they want to be as far apart as possible. So there are 4 things attached to this carbon, okay, 4 bonds. So 109.5 was the angle which was shown by the which was proved by the Vesper theory. But what about this thing? We just saw that one of the orbital has 2 electrons into it. The 3 has one electron with it, okay? So nitrogen can produce 3 bonds with those, but in 1 electron it will keep what? Its lone pair, okay? But these all bonds are sp3 hybridized. Nitrogen is using its sp3 hybridized orbital to make bond with hydrogen, sp3, 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 and this is a lone pair, but keeps a lone pair into sp3 also. So what will happen, because in nitrogen we saw that, suppose in the methane case we saw that it should be tetrahedral. Now again, if this orbital is sp3 hybridized, this is sp3, so what? It needs to be a tetrahedral, but no, it is not, because the lone pair, it exerted more, it pushes the bond pair more. If there are 2 bond pair, from bond pair what I mean, this CH, okay, this is a bond and it has a pair of electrons, so it's a bond pair. It is a bond pair, but it is lone bonding electron or a bond pair. So they say that the bond pair pushes the lone pair or the non-bonding electron, they pushes the bond pair more, okay? So the normal tetrahedral of the CH4 molecule, it has an angle of 109.5 between these. Suppose this is carbon and these are all bonds, and there are 4 hydrogens attached to it, okay? So it should have normally an angle of 109.5. But what if this is again, it is forming 4 things are attached, but here hydrogen, but here it has some non-bonding electron. What they say? They say the non-bonding electron occupies more space. If it occupies more space, then it pushes the other things more, okay? So let's say, for example, this one, suppose we say that this replace this with a lone pair, okay? Now what will happen? The other 3, it will shrink them because it is pushing them, so they will come near to each other, the angle between them decreases, okay? It is in sp3, this is sp3 hybridized orbital which is having the lone pair, non-bonding electron. It is a little bit bulkier, suppose, or in fact it is, and it exerts more pressure on the other thing, okay? And it make them shrink, okay? So the angles between these angles are about 107, okay? If it were nitrogen has some hydrogen attached without a lone pair, it should be 109.5, but now it has a lone pair attached. The lone pair what the lone pair does? The lone pair pushes the other thing more, okay? Suppose this is lone pair and these are the normal bonds, it shrinks them. Okay, that's what the basic of the hybridization says, but in reality something else is happening, and we'll discuss that in advanced section, that how does the the increasing or decreasing of S character increases or decreases the bonds. Okay, we are not discussing it right here. It's a simple. So this is the molecule of nitrogen. It is not tetrahedral, it is called as trigonal pyramidal. Trigonal means, suppose it has 3 legs, because lone pair just shrinks them, the angles between each of them is less than 109.5 degrees. Okay, so this is the case. Now let's move to another molecule, H2O molecule, again a part of this series, OH, H. Its angle is even more less than 107 degrees. So how the hybridization is going to explain the experimental angles and the lengths. Okay, so as you know that here it has oxygen has 2 electrons. This is electronic configuration. Here in the valence electron in the valence shell, it has 1, 2, 3, 4, 5, 6 electrons. So it can make 4 bonds. Sorry, it can make just 2 bonds because it has 2 unpaired electrons. So how hybridization justified this thing? Now it form a bond. It is hybridized. It produces 4 hybridized orbitals. It Sp3 hybridized. With 2 of the Sp3 hybridized orbital, it forms bonds with the hydrogen, and the two hybridized orbital, it keeps it in what? It keeps the lone pair into the other hybridized orbitals. Okay, so this is Sp3, 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 and Sp3. Okay, so as you know that the bond pair is pushed harder by the lone pair, but if there was one lone pair, it could push them like this. If both were present up, it could shrink them more. But now another thing it happens, both the lone pairs should avoid itself. Okay, it's because lone pair will repel each other more, so they will first avoid each other. They will be as far apart from each other, so they keep a big distance from each other, and that's how the angle of the H2O molecule is shrink even from the 107 degrees. Okay.